Welcome to Programming in Modern C++. We are going to discuss module 29 now. In the earlier 3 modules, we have been developing different concepts of polymorphism and the kind of specific support that C++ provides over an inheritance hierarchy. We have seen different types of casting, static and dynamic binding, virtual functions. We have looked at why destructors must be virtual on a hierarchy, why we need pure virtual function, what is abstract base class, and so on. So, in terms of dealing with a certain level of polymorphism, which typically what we are dealing with is the runtime polymorphism right now, along with some of the overloading which we have already learned, we have covered all these. Now, we are equipped, as an engineer, we are equipped with our tools. So, it is time for us to try out our tools on doing an actual design and implementation. So, the main objective of this module would be to understand design where there is a prevalence of easy related concepts, that is generalization, specialization, and we will start with a C design and identify why C is not an appropriate platform for dealing with such design requirements. But before we will start doing this, we will first take a quick look at some exercise for practice. So, this is your outline here, will be available on the left. So, I have put 2 exercises, actually one exercise on binding, having 2 different instance requirements. So, there is a class A which is specialized in B, which is further specialized in C, and there are virtual functions here. There is a non-virtual function, some virtual functions like G is inherited, but not overwritten, some are inherited and overwritten, some are inherited and made virtual, hiding the function of the base class. Then again you have some which is overridden into class C, others just inherited. So, if you have this kind of a class hierarchy and if you construct objects of 3 classes A, B and C, and you have 2 pointers, one is of type A and another is of type B, then you should be able to work this out. There are 3 functions f, g and h. Of that you can see that f does not have any overload, G also does not have any overload, but if you look at H, you find that there is overload, right. So, there are 4 different function signatures to deal with. So, I would need you to fill up this matrix, that which function will be called with PA pointer FA if PA is initialized with the address of the A object. So, similarly do that for each 4. Again, a different instance is if you initialize, if you assign PA with the address of the B object, which functions will be called and so on. So, please work this out and do not look at the answer, it is on the next slide for your verification, but first work this out and then check that you have done it correctly. This is I am putting this so that it is very, very important that you understand the static and dynamic binding of function calls in a very solid way. That is, overriding, overloading, polymorphic virtual functions must all be very clear to you. So, please work this out. This is the first part of the exercise. I will skip the solution slide, which is after this. The second part of the exercise has exactly the same problem, exactly the same instance, except that now we are using PB. Earlier we were using PA, now we are using PB, which is pointed to the B class, and all the three cases, in all the three cases, PB is assigned the address of A object, address of B object, and address of C object. You have to comment, you have to write what will happen in all these different 12 cases. Mind you, out of the two kind of instances of this exercise that I have just discussed, it is possible that some of the function calls or some of the instantiation may not actually compile. So, it may give compile time error, it may give runtime error. You have to consider all of that, and if you think that certain cases have this error, you write down that error itself. Again, like the first part, the solution is given in the next slide, which you refer to only after you have solved this. So, I will skip the solution. Okay. Now, let me come to the meat of the discussion in this module. What I would do from here till the end of this week, that is covering the next module also, we will try to solve a simple yet quite illustrative problem, which will show us how really the inheritance and polymorphic strengths must be used. And we will do this through a process of iterative refinement, I would say. That is, we will start with a very initial first cut solution, which easily come to our mind, and we will try to implement that, identify the problems therein and try to rectify that using the proper modeling, and again look at what are the gaps that still remain, and keep on doing this till we come to a solution which is acceptable and which is nice. So, let me state the problem for once. The organization, there is a staff salary processing requirement. This is an organization which has different staff, and it needs to process the salary of the staff. So, let us assume that initially there is only an engineering division where engineers and managers work, and every engineer reports to a manager. Every manager can also work like an engineer, right? But primarily the manager's task is to take reporting from the engineer. Now, naturally the logic of processing salary for an engineer and a manager would be different, right, because managers would have different kind of salary structure and so on. Not only they will have different salary, but they will have different kind of salary structure. Maybe they have bonuses, maybe they have stock options and different heads and so on. So, different functions are required for processing the salary of the engineer and processing the salary of the manager. This is at the present. Now, in future it may add, the organization may add directors to the team. So, that directors will be responsible for broader business goals, and every manager will report to some director. So, and a director could also work like a manager if needed. Naturally, the logic of processing salary for the directors will also be distinct from the managers as well as the engineers. Even further down in future, what happens is the company, the organization may decide to open other divisions like sales division, like HR division and so on, and expand the workforce. And again, there will be such generalization, specialization relationships and different processing requirements. So, what we need to do is, given this simple problem, we need to make a suitable design which can be properly extended as needed over a period of time. So, we start by asking ourselves a couple of questions which we will keep on asking repeatedly, because if we want to do the design, then first you need to set certain parameters for the design, and some questions very commonly naturally will come, which we need to address. For example, the first thing obviously is how to represent engineers and managers. Right? Obvious, we are in the domain of C. So, they will have certain attributes. So, we will put them into structure. So, we will have a collection of structures, one for the engineer, one for the manager, and so on. How do we initialize these objects, engineer or manager objects? We need to write initialization function. We have seen that before in terms of stack example and so on. Now, how do we have the total aggregation collection of staffs? There would be engineer objects, engineer structures, there will be manager objects, manager structures, different types. So, how do we put that together? We have learned in C, the way to do that is to put them as a union. Okay. So, that it could be either a manager or an engineer, but not both. And then I need a collection for that. So, I have an array of union. Right. I am just trying to ask the natural questions that will happen and try to identify what is the language feature, what is the design feature that we will use to get to that solution. Now, the next question is how do we model various salary processing algorithms? Right? They will be different. So, we need different functions for every structure type. So, we need different salary processing for engineer, different salary processing for manager, we have to implement separate functions. Now, the final question is, having done all this, how do I uniformly treat the entire collection of staffs and process their salary in their respective way? So, how to invoke the correct algorithm? Like here I have the collection of all the employees, all the staffs, but for each I have different processing algorithm. So, for processing the salary of all employees, I have to pick up every employee from this array, check what is the type, is that employee an engineer or is that employee a manager, and accordingly call the respective processing function. This kind of a requirement where we make decisions based on the type of an object is known as a type switch. Right? So, we can implement that using a function switch or we can implement that using function pointers. Right? So, this is the basic level of analysis that goes into solving this problem. Now, let us get down to some code. Say the first thing I need to know is I need to know whether some employee is a manager or an engineer. So, how do I keep that? I create an enum e type with 2 tags. So, that if some employee is an engineer, we will say ER, tag it as ER, other we will tag it as MGR. Right? Now, we need to have the structure. So, I define struct engineer. For simplicity, I have just kept the name, other fields could be there, and type def that as engineer, so that I do not have to write too much. As already identified, I need an initialization function. So, that initialization function must take the name and return me an engineer pointer. In C++, it would be the constructor, but here we do not have that. So, we dynamically allocate the memory, copy the name and return that pointer. Right? Very simple thing to do. Now, having done this, the next is the same. Okay. The next obviously is I need a processing function. So, I say process salary engineer, which takes an engineer pointer and does the processing. Just as a placeholder, I am doing a printf. Similar design I do for the manager, right. And then, so I have tags ready, I have objects and their processing ready, their initialization ready. Now, I have to put the collection of the staffs. So, I need to, a staff can be an engineer or a staff can be a manager. So, I need to unify these two types. So, I create a union of engineer pointer and manager pointer. But then that classical question as to how do I know which type of pointer it is. So, I have a tag which will say which type of pointer it is, whether it is an engineer pointer or a manager pointer, and then I aggregate these into a structure. Right. So, this becomes my staff entity. This is my engineer entity, this is my manager entity, this is a wrapper. This structure with the E type tag becomes my employee entity. Right. Let us move on. So, once we have that, then my actual staff would be just an array. So, I put an array keeping a maximum number of staff. Now, to create every engineer, suppose Rohit is an engineer. So, what do I have to do? I have to do a create the Rohit object. So, do init engineer for Rohit because he is an engineer, put it to the PE part of the type def, PE part of the union and tag it as ER. Kamala is a manager. So, I initialize that, put the tag as manager, I do that for all the employees. So, my collection is ready. Then finally, to process the salary. To process the salary, what do I have to do? I have to do it for all the staff. I have just hard coded it here to keep things simple. Then, as I go along this array of staff, I pick up the first element and check what is the type. So, I take that in a E type. What are the possibilities? It could be an ER or it could be a MGR. So, I check with whatever I have got, I check with ER. If it is true, I call the, I know that this is an engineer record. So, I call the process salary engineer with the respective engineer pointer. If it is not, I check whether it is a manager. If it is, then I do process salary for manager with the manager pointer. Otherwise, if for some reason it should not happen, but otherwise if there is some other tag that has come, then I say it is invalid. So, that is an exception. Do that, try to run this, this is given below is the output that you will get to see the salary has been processed. Right. So, we have a first cut design for the problem. Now, let us extend it a little bit. Let us also introduce directors and see what we have to do. We have solved this for engineer and manager now, and we are told that soon directors are going to come. So, as we introduce directors, there is none of these questions will have a different answer. Right? So, we have the same answers, same design perspectives. All that we need to do is to actually go ahead and implement. So, what do I need to do? Now, directors are there. So, I need a third type of employee. So, I introduce DIR here. My engineer does not change, my manager does not change, but I will have the director created in the same way, defined in the same way with the structure, with the manager reporting, with the director initialization and the process salary director, a new function. What do I need to do for the staffs collection? I earlier had engineer and manager, I have to introduce this. So, this is what I need to introduce, this is what I need to introduce, this is what I need to introduce. These are the changes from my earlier design that I am having to do, distributed at different places. Right? Having done that, let us see. Now, there is no specific change in terms of this array. In the similar way, I create different staff instances, but coming back here, I need to add another if condition. This is my type switch or my function switch, because now I have a new type of object, the director object, requiring a new type of processing function. So, if else like this, it will. So, the total changes, the changes that we had to do earlier and in the earlier slide and this one, and then this design now works for engineer, manager and director. This is just to show you a different implementation of the main function. Instead of the if else change, you can also use a switch, which at least looks cleaner. You know, if you do if else and every value of this tag is a constant. So, that is an ideal case for writing a switch. So, this at least will look sane if there are number of 10, 20 different types of employees, otherwise this if else chain will become very, very long code. But that is just a kind of management, code management issue. Now, let us evaluate what have we got. So, let us look at the advantages and disadvantages. The first advantage is that the solution exists, that is the first thing, right. If you are working, the first thing you need to do is to make sure that it can be solved. Then comes good solution, extendable solution, robust solution, testable solution, verifiable solution, all of that will come later. So, the first thing we have got, the solution exists. The second we observe is the way we have been analyzing very clearly and writing the code step by step based on our analysis, it has a well structured pattern. You have a tag, you have a structure, initializer, a processing function, you have a wrapper for the union of different types, then an array for this, and finally, a type switch. So, there is a certain nice pattern in this, but it has a lot of disadvantages. For example, the employee data has lot of scope for better organization. The first thing missing is there is no encapsulation. C has no encapsulation. So, structure is everything is public. Then we are having to duplicate fields across types of employees. For example, every employee has a name. So, every structure must have a field called name. Right? We may mix up in the name of that field. I may call something as name. Someone later on may want to call it as ename, someone may call it as name underscore. So, there is confusion. Some might want to say that this is a cat star, some might want to say that this is a const cat star, and so on and so forth. So, this kind of duplication of fields, same fields which mean the same thing across different types, are really difficult in the object modeling. Objects are created and initialized dynamically through init functions. So, what we have missed out is how to clean them up. So, I just wanted to keep the idea simple, but you see that as you need the init, you will also need to provide a way to clean up the memory, right. You need a releasing function, and that releasing function, like the processing function, will again have to be called based on the specific type. You will come across another type switch there to release, because all structures will not have the same set of fields, and therefore, they cannot be released by the same code, right. Lot of issues, right. So, this is about the overall data modeling. Then the more severe problems are objects are managed, types of objects are managed explicitly by e type, right. We are putting a tag. So, what did we have to do? To extend the design, to add a new type like director we did, I needed to add a separate code to e type, add a new pointer field in the struct stuff in the aggregator, so that I can point to that, and add a new case in the if else or the case switch. So, if all of these, and if we have the releasing function, we will have yet another switch to deal with. If all of these are not correctly done in every case of addition of a type, we are going to get into severe problem. So, this makes the developer has to decide to call the right processing function for every type. All of these will need a lot of development care. Right? So, that is going to be a serious drawback for this design. Finally, here we have seen earlier that function pointers, because we have different types of functions for processing. So, instead of function switch, could we not have used function pointers? We would have liked to, but the difficulty here is that the employee processing, the engineer processing function takes an attribute, takes a parameter which is engineer star. The manager processing function takes an attribute, takes an argument which is manager star, director star, so on. So, all of their arguments are different. So, I cannot have a common signature through which function pointers can be directly dispatched. Right? So, function pointer based approach on this design, the way we have done the design, will also not work. So, we are losing out on that ability. Now, after the analysis, what comes is a recommendation. So, the recommendation is to use classes for encapsulation on a hierarchy, and that is the refinement we will start working on. Right? So, to summarize, in this module we have provided some practice exercise, but most importantly we have started designing a staff salary problem. We have worked out a C solution, and we have shown what are the various shortcomings of that design, starting from modeling of the object as well as processing through type switch, as well as being unable to use function pointers and so on, which in the next module we will keep on refining with C++ and go to a better design. Thank you very much for your attention. See you in the next module.